What I have on this board are chunks of salt. I'm using Himalayan pink salt because the coarse salt works best for this demonstration. Now, if I hit it with a hard object, you can see that it easily crushes into smaller chunks and grains. But why is that? What causes salt to be so brittle?
This is because edible salt, or sodium chloride, is an ionic compound with the chemical formula NaCl. All ionic compounds are brittle as solids due to how they're structured, so let's review some important information about ionic compounds first. An ionic bond is formed between a metal and a nonmetal, both of which are ionized. A positive ion, or a cation, is the metal that loses electrons to gain its positive charge. A negative ion, or an anion, is the nonmetal that gains electrons to get its negative charge. We must remember that opposite charges attract, and like charges repel. Going back to sodium chloride, a sodium ion, which has a charge of +1, is bonded to a chlorine ion, which has a charge of -1, to create NaCl. Here's a 2D model of a layer of NaCl to explain what happened in the demonstration. Notice how the cations and anions are arranged. This is because, in all ionic solids, ions are arranged to maximize forces of attraction between oppositely charged ions and to minimize repulsive forces between like-charged ions. So, what happened when I hit those chunks of salt earlier? Well, the force I exerted onto the salt caused a layer of ions to shift so like-charged ions aligned with each other. Remember when I said like charges repel? Well, the repulsive forces generated from like-charged ions being next to each other causes the solid to break along planes. And that's why NaCl, along with every other ionic compound in its solid state, is brittle. Thank you for watching.